Hey everyone, welcome back to the channel. Today we are diving into essential topic in theoretical computer science, context-free languages or CFLs and their closure properties. Whether you are a computer science student or just a curious about how languages in programming work, this video is for you. So, let's get started. To begin, what is context free language or CFLs? A CFL is a type of formal language that can be generated by context free grammar CFG. If you are worked on programming languages or compilers, you have already encountered CFLs. They play a key role in syntax checking and phrasing. Think about the languages of balanced parentheses. For instance, two brackets is balanced, but one bracket is not. This is kind of structure in an example of what CFL can describe. CFLs are represented using push down automation, PDA, which is like a finite automation, but where memory is form of stack. Next, let's discuss about closure properties. The idea of closure property is simple. If a set of closed and if set is closed under a operation, it means applying the operation to the elements within the set results in a element that also belongs to the set. For CFLs, closure property are incredibly useful for understanding which operations preserve the language CFL status. This knowledge is vital in areas of compiler design where transformations and combinations of languages occur. There are several operations commonly studied for CFLs. These include union, combining two languages, concatenation, joining strings from two languages, clean star, repeating string any number of times, intersection with regular languages. Uh, some of these operations, like union concatenation, preserve the CFL property. Others, like general intersection and complementation, do not. Let's start with union. CFLs are closed under union. That means if L1 and L2 are CFLs, their union is L1 union L2 is also a CFL. The proof involves constructing a new CFG, add a new start symbol, say S, and include the production rule S is to S1 bar S2. Then combine the grammars of L1 and L2. This ensures the resulting language is still context free. Next, concatenation. CFLs are also closed under concatenation. If L1 and L2 are CFLs, the concatenation L1 into L2 is a CFL. To process, the process is similar. For CFG, G1 and G2 generations L1 and L2 respectively, we create a new CFG and the rule S1 is to S1 S2 where S1 and S2 are the start symbols of G1 and G2. Combine the production rules of G1 and G2 and you're done. Clean star. Clean star is another operation under which CFLs are closed. The clean star of a language denotes L star, includes all possible concatenation of strings from L, including the empty string. To prove this, we define a new CFG with new start symbol S. Add a production rule S is to epsilon slash SS1 where S1 is the start symbol of the grammar of For L, this recursive rule ensures the grammar generates all possible strings in L. Non, not all operations preserve the CFL property through CFL are not closed under general intersection and complementation. Take the intersection of two CFLs. L1 is equal to A par n, B par n, and L2 is equal to B par n and C par n. Their intersection will be A par n, B par n, C par n. Is not a CFL because it requires comparing three different symbols in a sequence with a PDA, which PDA cannot be handled. Now, why should we study CFL closure properties? These properties have practical application in areas like compiler designing, ensuring the syntax of the programming languages is correct, phrasing algorithms, efficiently recognizing whether a string belongs to the language, formal language theory, understanding the transformations and relationship between languages. From writing a code to designing new programming languages, CFL and their properties are the heart of the computer science. In summary, closure properties of CFL helps in understanding how these languages behave under various under various operations while they are closed under union, concatenation and clean star. They are not they are not closed under general intersection or complementation. These insights are foundational in areas like phrasing, compiler design and beyond. If you enjoyed this video or learned something new, please give a thumbs up and consider subscribing to the channel. Thanks for watching. I'll see you in the next video.